Well, the first part, this is all, we'll do the review part because this is the easy part. Okay. All right. So just to review, yes, if you get infinity over infinity or 0 over 0, which we'll also do, we have multiple indeterminate forms. So there's infinity over infinity. We have infinity times 0, infinity minus infinity. And then we have even more, 1 to the infinity, 0 to the 0, and infinity to the 0. Okay. So 0 over 0 is the easy one. We just do derivative at the top and derivative at the bottom, right? So this will just be, and if you were going to do this on a free response question, you would just write out the numerator and the denominator, show that they're zeros, but I don't need you to do that. We can just apply it. We get cosine over 2, and then we can evaluate it, right? So that becomes, yeah, sorry, cosine of outright x, and then we can just evaluate it. So sorry, so this will just be 1/2. Here, again, this algebraically we could just factor, but it's probably faster just to do the derivative at the top and the bottom, and we get 1/6. Okay, so the stronger form is just basically like you can keep going. You could do derivative after derivative until you no longer get 0 over 0. Okay, so this one, what do we get? Okay. We got what? Negative cosine over negative 2 sine 2 theta. Of course, if we plug in pi over 2, that's going to still be 0 over 0, right? Cosine of pi over 2 is 0. So we have to do it a second time. Here we get positive. Right, and in the denominator, negative 4 cosine 2 theta. And now what do we get? So if we plug in pi over 2, 1 over, well, that'll just be cosine of pi, so that'll be negative 1? 1 over 4. Okay. Okay, just trust me, you get 0 over 0. So 2x minus 4 over 3x squared minus 12. And we get 1/6. Perfect. So half of the lesson will, like the homework problems, they're all just going to be like this, review from last year. And then we'll get into the new stuff. All right, one-sided limits, same thing, right? So what happens in A, we have a vertical asymptote. But, right, it's still 0 over 0. So cosine x over 2x. Okay, now be careful here. The numerator would now be 1, 0, so that does not exist. also goes to infinity. This one, what do we get? Secant squared over 1. Cosine of 0 is 1, so it's 1. Okay. Oh, I just put in here. Just remember, these forms are not numbers. They're descriptions of the function's behavior, right? So. Good so far? Identify the indeterminate form, and then we want to evaluate it. Well, it's like indeterminate form, just saying it's 0, 0. Yeah, 0 over 0, infinity over infinity. Infinity, like, we'll have some other ones down here that are new. So this one is infinity over infinity. I'll just write. Right, because there's, at pi over 2, there's vertical asymptotes. Okay. Derivative of secant. And derivative of tangent. So I would probably simplify this. Yeah, and tangent, right? So if I cancel this, and tangent is sine over cosine, and secant is 1 over cosine. So how does that simplify? So just sine, which gives us...
Wait, how did you get that it was infinity over infinity?
Okay, so if you think to the secant graph, which is the 1 over cosine, right? So what happens at pi over 2, 3 pi over 2, and so on? Do you remember that? You don't remember? Here. Let me. So if we just graphed the, like, cosine. Well, yeah, but like if I were to graph everywhere that it crosses the x-axis, it's going to have... So it's going to go like this, like that. Do you remember that? Yeah. Okay. So what's happening when we approach pi over 2? I probably should put from the right or something like that, but or from the left. So it's going to infinity. So what if you add 1 to that? It's still going to go to infinity. And then same thing for the tangent. Remember the tangent? Good. Okay, this is infinity over infinity. So derivative of natural log is 1 over x. And that will be what's going to happen. So it'll be 2, and then, yeah, the derivative of square root of x is 1 over 2 root x. So it'll just be 1 over root x, which I can simplify to 1 over root x.
I just what am I
Well, think about if I took this, right? I could make this root x over x, and then think of that as x to the 1/2 over x to the first power, and subtract the exponents. So this whole thing will go to 0. Okay, now we're getting into new territory, because this one is going to be infinity times 0, right? The x will go to infinity, and the sign of 1 over x, as x goes to infinity, that will go to 0. Okay, so I want to rewrite this as a quotient. Any ideas?
Right as a quotient.
I'm going to do something with the x. I'm going to make it sine of 1 over x over 1 over x. Okay, do you agree those are equivalent? If you divide by 1 over x, it's the same as multiplying something times x. Now, you wouldn't have known to do that. This is new, okay? What we end up doing for something that's not an infinity over infinity or 0 over 0, 0 over 0, we make it that. We make it that form. So now what is the form? Now it is 0 over 0. So it starts out as infinity times 0. Turns into 0, 0. Now we can do L'Hopital's rule. Okay, so that's going to become cosine of 1 over x times negative 1 over x squared over negative 1 over x squared.
Why does it really go sine of 1 over x?
Because chain rule. Because remember, this is x to the negative 1.
Oh, yeah.
So if it's x to the negative 1, it'll become negative x to the negative 2. And look how nice that works out, which becomes cosine of 0, which is 1. Again, just to remind you, this is the behavior of the function. That means as x approaches infinity, this graph is approaching 1. Should we do one more? And then if you want to do your physics.
I feel like I've reached the point of like I feel like I start gassing myself that like I know what I'm doing and I don't.
Okay, this one is infinity minus infinity.
I'm making it first would be like divided by negative reciprocal.
Well, let's find a common denominator.
Oh.
How's that?
Sorry.
Let's find a common denominator, because then we'll have it all as one fraction. You know what I mean? Oh, it's going to be
I think we
fine.
should do all of this. We can do homework with you tomorrow.
Let's see. X minus 1 minus natural log of x.
Yeah, I just don't wait. I would not do it. I cannot. I'm for the first time since nursing school and going home after school.
Okay, this one is going to give us, now we have, this has now turned into a 0 over 0.
So
Right.
just find a common.
That's all we had to do here. So it started out as infinity minus infinity. By combining the two terms, we get 0 over 0. That's where this, tends to get a little bit more difficult. Okay, that's going to turn into 1 minus 1 over x. Oh, denominator, we have to do the product rule. So 1 over x times x minus 1 plus natural log of x. Because you have to do the product rule.
Oh, right. I always do it the other way.
Okay.
So it's 0.
Well, we still get 0 over 0. Well, okay, we have a couple options. We can also try to simplify it because sometimes that might help.
Let's just do it again.
Really?
No.
No. I'd multiply the top and the bottom by x. Just, if I multiply everything by x over x, that'll be x minus 1 over x minus 1 plus natural log of x. Oh, x natural log of x. My mistake here. Here's the reason. If I were to do the derivative of the top, I'd end up with 1 over x squared, and then in the denominator, I'd have to do the product rule again. Notice now, I still get 0 over 0, but notice what happens when I do the derivative of the top. It's just 1. So I know I'm basically done after this step. You know what I mean? Okay, so I'm going to do L'Hopital's. So that's going to give me 1 over 1 oops. Yeah, so we'll get 1 in the numerator. In the denominator, we get 1, and then we have to do the product rule. So that'll be 1 times natural log of x plus x times 1 over x.
So if we do the product rule, we're not taking the derivative.
Yeah, we are. We had to do L'Hopital's rule one more time.
Yeah.
So we did it at the top where it's in pink.
Yeah.
Then the next step was just doing some algebra. But then I still get 0 over 0 here.
Right. And then
So now I have to do L'Hopital's rule.
yeah,
So
but then
this...
you have to do it again afterwards. 1 over...
No, because I have a 1 in the numerator. So as soon as I get 1 in the numerator, plus, what's this going to give us? This is going to equal 1. So I end up with 1 over 1 plus 0 plus 1, which is a half. Are we good? Do you want to keep going?
You get 40% and get... Well, he just decides what his average is. Like last time, the average was 56. He literally said he was like, I wanted it to be mid-70s, so I curved it, and now the average is 76.
Got it.
Yeah, so it's like, if we get a 76, then he won't curve it because that's what he wants. Yeah, but then we still have test corrections and we can correct it up to like a B. Also, why would you want your average in class to be 76 or whatever? Yeah. But I don't have average times good. Yeah, like, also, if literally the class average is 56, that should be tested to your teacher.
Okay, so this one, we're going to do logarithmic differentiation. So if you notice, all of these have an exponent of infinity or of 0. So what we end up, so if you remember, when we have a base, like if you look at these examples, you have a base that has a variable and an exponent that has a variable. So we want to get the variable out of the exponent by taking natural logs of both sides. So basically when we do that, we're going to end up with a value at the end that we're going to do e to that limit. I'll explain. Don't worry. Okay. So first thing, I'm just going to look at what form we have. This will be 1 to the infinity power. So that's the form. So I first am just going to let y equal that whole function. So just like what we did last year, and we reviewed it a little bit at the beginning of this year, I think. So we're going to take natural log of both sides. And that allows us to move the x to the front. Okay, now I want to take the limit of both sides. Oops. Hey, Lauren. Yeah, I think it's in the charger. No, it's still of x. Listen, because you're doing the same thing to both sides, right? Oh, yeah. So just think y, what is y? Y is a function of x, right? Yeah. So I'm going to kind of ignore the left side for the moment, and I'm just going to work with the right side. So if I take this into consideration, this is now an infinity times 0 problem. Do you see that?
What would be times 1? Oh, ln of 1 is
ln of 1, yeah. So so we took a 1 to the infinity power, we turned it into an infinity times 1, and now we want to change it to an infinity over infinity or a 0 over 0. Okay, so that we could do L'Hopital's rule. So I'm just going to work with the left side, and I'm going to rewrite this as natural log of 1 plus 1 over x over 1 over x. And there's a reason there's a lot of space for these. I realize I probably should even have more room. Now it's 0 over 0. So now, sorry, probably should have left more room. Bless you. Okay. So it's going to be 1 over 1 plus 1 over x times negative 1 over x squared over negative 1 over x squared. That trick is going to happen a lot. Okay, so if you have like x times something, rewrite it as 1 over x in the denominator, and you'll notice those are going to cancel. And what do we get? Just 1. Right? 1 over 1 plus 0. So we get 1. Now we've evaluated the limit as x goes to infinity. So now we go back. Remember how natural log of y was equal to that limit? So natural log of y equals 1. Therefore,
isn't it like the limit as x goes to 0?
Yeah, but we evaluated the limit. Okay, so even though I said it was of both sides, basically whatever we get here, right, that's going to be our natural log. So natural log of y equals 1. So y equals e. Therefore, the limit of this original is equal to e. So if you look back here, it's always going to be whatever you get your limit. Okay, so we got 1 for our limit. So it's always going to be e to whatever that is. So in that case, it was e to the first power. Does that? Oh, this one's actually easier. Okay. And this one's easy. We actually don't have to do any real manipulation. I just changed it so it's natural log of x over x. So now it's infinity over infinity. So derivative of natural log is 1 over x over 1. We get 0. Are we good with that? I don't have to, you don't, yeah. I don't have to go back. Like, it's always going to be natural log of y is going to be equal to that. So, like I said, you can just jump right to e to whatever we get here is the answer. What do you think? What do you think? You want to just finish it off? Okay. So this is 0 to the 0.
Does it matter that it's 0?
What's that?
Does it matter that it's like 0?
Oh, yeah, just technically it's just to say like one-sided derivatives, we treat them the same. Plus what's going to happen here, we don't want to have the negative side because we're going to take natural log. Is it just 1?
But like 0 to 0 is 1.
So, okay, what you have to remember, so 0 to the 0 is considered an indeterminate form. Any real number to the 0 power is going to give us 1. But these are not real numbers. This is end behavior of a graph. Or not just end behavior. This is the behavior of the graph as we approach 0 from the right. Like, do we think it's going to be 1? It's not. My point is, it's not. The rules for real numbers do not apply here because it's behavior of a graph and it's a limit. So limits are not, remember, limit is what it's approaching. Doesn't have to have the value there. Okay. So now we evaluate this. Okay, so that's going to be a 0 times, well, technically a negative infinity, so it's still a version of infinity. So how can I rewrite this?
So that's 0 times infinity.
ln of x over 1 over x. Okay. Now basically I have like a negative infinity over a negative infinity, so it still applies. So we will do L'Hopital's rule now. So that's going to be 1 over x over negative 1 over x squared. Which is just going to be negative x, right? If we flip it, which ends up being 0. So Sydney was right.
Why would we do all this work?
Because not every indeterminate form of 0 to the 0 power is going to result in a 1. Really?
I don't get why it would.
No, you could just write e to the 0 equals 1. It's just generally speaking, because we did a lot of work, and I just want to make sure it's clear that the answer is going to be 1.
I don't understand how every time you do that.
Because there's different forms of 0 to the 0 power. Like what if it was sine x to the 0 power? Do we know for sure then? Or what if it was like there's different functions that could result in the same, but that doesn't mean their end behavior or the behavior at a particular value is going to be the same. Okay, I promise. So this is going to be infinity to the 0 power. What's wrong?
I'm just noticing natural log of natural log.
Okay. Well, because it's the natural log of the natural log, it's a composition of functions, and they're not inverses of each other. So now if I rewrite it like this, now I have infinity over infinity. Because think about the inside natural log of infinity, that's going to infinity, and the natural log of that will still keep going to infinity, and the denominator. So now I can do L'Hopital's rule. So it's going to be 1 over natural log of x times 1 over x over 1, right? So that's just going to be 0. Therefore, we get e to the 0, which is 1.